Learn how to code a chess game that can be played against another person or a computer using the Stockfish API. This course from Robert uses Angular, but you can still follow along if you're new to Angular.
Hi and welcome to this comprehensive tutorial where I'm going to teach you how to build a full chess application from scratch using Angular. Even though you may not use Angular, I will explain everything in detail, so it will be easy for you to follow and implement it using your preferred language and framework. Application consists of two parts: playing against friend in the same browser, where we implemented correct piece moves. We also implemented special moves like EnPassant capturing. Also implemented check detection. Pawn promotion. And castling as well. Here we have game history component, which shows us moves that have been previously played. If we click on one of the move, it will simulate how that position looks like when that move has been played. Finally, we are going to use Stockfish REST API in order to be able to play against computer. In our application, click on Play Against Computer button. Dialog shows us to choose between different levels of Stockfish strength and also to choose color for our pieces. We are waiting for computer to move, and as we can see, everything works fine. If that sounds interesting, let's start with tutorial. Before we start writing any code, my goal will be to first clarify how things should be done, and then we will move on to the writing code part, because if we know exactly what needs to be done, writing code is the easier part. Although the code is written using Angular and TypeScript, if you understand the basic logic behind the application, it will be clear to you how to implement it using other languages and frameworks. So let's first start with the object-oriented model for our chess application. On the one hand, we will have the chessboard, and on the other hand, the pieces. For the chessboard, we are going to have several basic properties like chessboard, which is two-dimensional matrix of pieces, player color, which is color of the player which turn is now, and chessboard view, which is getter that represents board as two-dimensional matrix of characters from which UI can print the board. For pieces, we will have FEN char, which is short name for piece. For now, you don't need to worry about FEN notation. We will talk about that later. Also piece color, which can be either white or black, and directions in which piece can move, represented as array of coordinates. Here are FEN characters for each type of the pieces for both black and white pieces. As you can see, FEN char is simply first letter of piece original name, and for white pieces it is represented as uppercase letters, and for black pieces in lowercase letters. Here is the coordinate system for our chessboard. X represents board rank and Y represents board file. And finally, I want to make difference between piece safe squares and pieces directions. As we can see, both queen and king have same directions, but queen can move multiple squares along one directions, while king can move only one square at a time if we don't counting castling as move. In terminal, create new Angular project, chess game, and once it is completed, open Visual Studio Code and we can start with coding. We are in Visual Studio Code. In app folder, create chess logic folder, then pieces folder and declare piece.ts file. Now declare abstract piece class that has protected abstract property FEN character, which is of type FEN character that we are going to define later. Also protected abstract property for pieces directions, which is type of array of coordinates. And through constructor, define private property color, which is type of color. Now we need to define getters for those properties. So firstly define getter for FEN character. Now define getter for piece directions. And finally define getter for piece color. Now in chess logic, create models.ts file, and here we are going to declare those types. So firstly, define enumeration for piece color. Color could be either white or black. Define type for coordinates, which is object that has x and y property, both type of numbers. And finally, define enumeration FEN char. And here we are going to define FEN character for each type of pieces for both black and white colors. White pieces are represented as uppercase letters, while black pieces are represented in lowercase letters. So now just copy white pieces and change white to black. Now in piece class import those types. And finally, after we are done with that, we can start implementing those abstract class for each type of piece. Now we are going to create bishop.ts file. Declare bishop class that extends base piece class. Now implement inherited properties. Bishop could move in 4 directions. All of them are diagonally, as you can see in the picture. Now specify bishop color through constructor. Now call the super constructor and implementing FEN character that depends on the color of the piece. So if piece color is white, then FEN character white bishop, otherwise FEN character black bishop. Now create knight.ts file. Then declare knight class that extends base piece class. Implement inherited properties. Knight can move in 8 directions, as you can see in the picture. Now we are specifying all of them. Now specify piece color through constructor. Call the super constructor and implement FEN character property that depends on the piece color. Again, if piece color is white, it's FEN character white knight, otherwise FEN character black knight. Now create queen.ts file. Declare queen class. that extends basePiece class, implement inherited properties. Queen can move in 8 directions. Now specify piece color and again call superconstructor and implement FEN character property. So if piece color is white, then it's FEN character white queen, otherwise black queen. Now create Rook TS file. Declare Rook class that extends basePiece class. Implement inherited properties. Rook can move in 4 directions. Now specify a Rook color through constructor. Call superconstructor. And implement FEN character property. If the color is white, then it's FEN character white Rook, otherwise FEN character black Rook. And now we are going to have one additional property, has moved, which signalizes if Rook has moved. And that property is important because castling can't be done if one of the Rook has moved. And here declare getter for has moved property. And also setter that takes no arguments and it just sets has moved property to true. Now create king TS file. Declare king class that extends basePiece class. Implement inherited properties. King can move in 8 directions, same as queen. So now we're copied directions from queen and paste it in king class. Now specify king color. Again call superconstructor. Implement FEN character property. King also have private has moved property, same as Rook. And now from Rook class just copy getter and setter for has moved. Now create pawn.ts file and declare pawn class that extends basePiece class. Implement inherited properties. And now for pawn directions we are specifying all possible moves for white pawn. Later we are going to create method to change those directions if pawn is actually black pawn. Call superconstructor, implement FEN character, now define private method set black pawn directions that changes directions if pawn has black color. We just need to change x property to x times -1 for black pieces. Now if piece color is black, we need to call set black pawn directions method. And also need to declare private has moved property. Private has moved property is responsible to manage if pawns have ability to move 2 squares straight, because initially they have that option. But after each move we need to restrict that. So firstly copy getter and setter from Rook class and paste it in pawn class. And now copy directions. So when pawn has moved, we need to update directions by restricting that coordinate that says that pawn can move 2 squares. And now if pawn is actually black pawn, we need to call private set black pawn directions method. Now create chessboard TS file in chesslogic folder and declare chessboard class. Declare private chessboard property that is two-dimensional matrix of pieces or null, where null representing empty square. Define player color, which is color of current player. Initially white is firstly playing. And in constructor, implementing chessboard property, define first white rook, then white knight, then white bishop, then white queen, white king, then bishop again, knight, and rook. Now specify white pawns. Need to copy that 7 more times. Now need to specify 4 empty rows. And finally define black pawns and black major pieces. So here just change white color to black. Now define getter for player color. And finally define public getter chessboard view, which is responsible to printing the board. So here we are looping through chessboard, and for each row we need to see if that row contains square which has piece or its empty square. So if piece is instance of piece, we need to return its FEN representation. Otherwise we are returning null. Import FEN character. Now close all the tabs and open terminal and generate component that is responsible for rendering chessboard in the browser in modules folder, and skip all the tests. Now open chessboard component TS file in modules folder, and here instantiate chessboard class as private chessboard property. Also declare chessboard view. And also declare public getter for current player. Now open chessboard component HTML file, and here declare div with class of chessboard. All of the CSS will be provided in the GitHub repository, so you don't need to worry about that. Now declare another div, and here we are looping through each row of chessboard view. Also declare x coordinate and give it class of row. So ng4 for let piece of row. Also declare y coordinate and give it class square. And for now just set coordinates for each square so we can see in browser how our board looks like. Now open chessboard component CSS file and here paste all of the CSS from GitHub repository, and now you can see what chessboard row and square class represent. And now in terminal start the project. Our project is live on port 402,000. Now in style CSS, paste some basic CSS and open app component HTML, and here remove all of the default HTML and just include our app chessboard component. Now in square class, append border and background color because background is initially set to black. Let's see how our board looks in the browser. So every coordinate is placed well, and if we compare that with original board, we can see that first row has first square black, then light, and second row has opposite. So in order to get desired view, we need to apply certain CSS classes. We are in chessboard TS file, and here declare public static is square dark method that takes x and y coordinates as arguments, and return type is boolean. So if both x and y coordinates are either odd or even, then square is dark. Now open chessboard component TS file, and here declare public is square dark method that takes x and y as arguments, returns boolean, and it calls static method of chessboard class. Now in chessboard component HTML, delete x and y coordinate, and for square append new class. So append dark CSS class if square is dark, but if square is not dark, it means that we need to append light CSS class. Those classes are just different background colors. As you can see in chessboard component CSS file. Now our board looks perfect. We applied dark and light squares correctly, and now we need to append pieces to the board. Now under the source and assets folder, you have piece folder with all of the images for each piece in SVG format. Now open chess logic folder, and in models.ts file, we are declaring the piece image path constant. That is read-only object that for its key has FEN character, and for value has path to this image. Now implement it by adding missing properties, and now we need to specify path to each image, so it's under the assets and pieces directory. In order to speed this up, you can copy this object from GitHub repository. Now open chessboard component TS file, and here declare public piece image paths property. And now in chessboard component HTML file, add image tag that exists only if piece is different than null, and append source tag that has value piece image paths of piece, and also declare alternative tag, and add class of piece. And piece class is actually just setting width of 50 pixels. Now all of the pieces are on its correct positions, and now we need to create functions that allows us to move pieces and play game. So now we are going to discuss how we can achieve that. Our goal is to implement a function that returns all possible save squares for the current player, so we can display save squares when user clicks on certain piece. Initially we define find save squares function that takes no arguments, and return type is map of the player available squares. That map is in format string for its key, which is in format x plus comma plus y, where x and y are initial coordinates of the piece, and for value we have array of coordinates which represents piece save squares. Initially we define empty map for the player available squares. Now we are looping through each of the pieces for current player, define empty list of coordinates that represents piece save squares. Now we are looping through each direction of the piece directions, declare new x and new y coordinates. If those coordinates are out of range, we can't continue along this direction. Now declare piece on new coordinates as new piece, which can either be piece or empty square. If that piece is not empty square and has same color as initial piece, we need to continue, because we can't put piece on the square that already contains our piece. Now we need to check if that position is safe after that move. We are going to see later what is meant by safety of the position. Then, if the position is safe, we update piece save squares list. After we done with traversing all of the pieces direction, we are checking for special moves like EnPassant and castling. If piece has any save squares, we are appending that to initial map for the player available squares, and finally we return that map of the player available squares. Now, to determine if position is safe after move, we firstly need to simulate how that position would look like after the move has played. And now, if the player who just moved piece creates position such that he is in check now, position is then unsafe, we need to restore that position and return safety of the simulated position. Now let's see this position. In that position, white is on move and white rook has only 3 available square. Let's say that it doesn't. So if he's moving on the one square that we are not specified, he will create position that he is in check now, which means that this position is unsafe. So if white creates position or black creates position in which he left his own king in check, that position is considered as unsafe position. To determine if king is in check, look at this position. To determine if black king is in check, we need to traverse through all of the white pieces and see if any of those pieces attacks black king. So firstly we are checking for white rook, it doesn't attack black king. Then for queen, queen also doesn't attack black king. Same for the rook, for the king, bishop, and finally we see that white knight attacks black king, which means that black is in check now. So here's the pseudocode. To determine if one side is in check, look through each piece of the opposite color. To determine if black king is in check, we are looking through all of the white pieces, and if one of the attacking square contains king with the opposite color, so in this case black king, then position is in check. If no such a square exists, there is no check. And finally, just one exception, that pawns are attacking in diagonal directions. We are in chessboard TS file, and here implement public isInCheck method that takes player color as argument of type color and returns boolean. We need to return false in case that position is not in check. But to see if position is in check, we need to traverse the board. So here writing 2 nested for loops. As you can notice, we here hard-coded 8. Now we are going to store that in private read-only chessboard size property. And now we need to see if that square is actually empty square or contains piece. So declare piece variable that is either piece or null. And here we are checking if piece is empty square or piece color is same as player color. If it is true, we need to continue. But now we need to traverse to all of the piece directions. And now declare new x and new y coordinates. In order to see if those coordinates are in range, we need to create new method, private rcoords valid, that takes x and y as arguments, returns boolean, and if both x and y are greater or equal than 0 and less than chessboard size, coordinates are valid. But now, if coordinates are not valid, we need to continue. Now we need to check if piece is either instance of pawn, knight, or king. and here declare attacked piece, which is piece or null, which is square at new x and new y coordinates in the board. And here we need to check if attacked piece is instance of king and has same color as player color argument of isInCheck method. If it does, we need to return true. Here I've wrongly typed false, but we'll correct that later. And if piece is instance of pawn and dy is equal to 0, we need to continue because pawns are only attacking diagonally. And here I'm also leaving a comment. Now if pieces are bishops, rooks or queens, they can move multiple squares along one direction, so we need to traverse all of that possible squares along each direction. Here we also need to check if attacked piece is instance of king and has same color as player color argument. So copy that from previous if statement and paste it. But now we also need to check if attacked piece is different than null. If it does, it means that we need to stop traversing along this direction because we reach certain piece and bishop, rooks and queens can't move over the other pieces. And finally we need to update new x and new y coordinates by incrementing them for the x and dy. Now we are going to implement a method that checks if the position is safe after move. Declare private isPositionSafe after move method that takes a couple of arguments. First is piece, and others are previous x, previous y, and new x and new y coordinates. And return type is Boolean. Firstly, declare new piece, which represents piece or empty square on new coordinates. And we need to check if that new piece is actually piece and has same color as the initial piece that wants to move. If it does, we need to return false because we can't put our piece on the square that already contains piece of our color. Also, I'm leaving a comment here. And now we need to simulate how that new position would look like at previous x and previous y coordinates. We need to put empty square. That's the reason why we are setting null. And at new x and new y coordinates, we are putting that piece. Now we need to check if that player is in check. By declaring isPositionSafe Boolean. So position is safe if that player is not in check after he moved piece. We now need to restore position. At previous x and previous y will be piece, and at new x and new y will be new piece. And finally we need to return isPositionSafe Boolean. We are in Chessboard TS file and here implementing private find safe squares method that takes no arguments and return custom type safe squares, which we are going to declare in models.ts file, which is basically map that for each key has string in format x plus comma plus y, where x and y, as we said, are initial coordinates of the piece, and for value has array of coordinates. Then import safe squares type, declare that initial map, and also return that map. Now we need to traverse through the board to be able to find those saved squares. Now we need to check if piece is empty square or piece color is different than the color of the current player. If it is, we need to continue. Also declare piece saved squares, which is initially empty array of coordinates. And now look through all of the pieces direction. Now specify new x and new y coordinates. Now we need to check if those coordinates are valid, because if they are not valid, we cannot process further. Also declare a new piece which represents square at the new x and new y coordinates, which can be either piece or empty square. And now we need to check if new piece is actually piece and has same color as the piece that wants to move. If it does, we cannot process further, because we can't put our piece on the square that already contains piece of our color. Now we are checking if piece is either pawn, knight or king. Now we are checking if position is safe after move. And we are passing piece, x, y and new x and new y coordinates. And if position is safe, it means that we can append those coordinates to piece safe squares, appending new x and new y. Now we are checking for other pieces. Bishop, rooks and queens can move multiple squares along one direction. That's the reason why we are having this while loop, because we need to traverse all of the possible squares along each direction. Here also declare new piece and checking if that new piece has same color as piece that wants to move. If it does, we need to break the while loop, because those pieces can't move over the other pieces. Now copy this if statement. If new piece is actually different than null, we also need to break, for the same reason that I mentioned a couple seconds ago. And finally we need to increment new x and new y coordinates by dx and dy. After we traversing all of the pieces directions, we need to check if piece has any saved squares. If it does, we need to append those saved squares into the saved squares map. And finally, we need to restrict pawn movements in certain directions. Because, for example, pawns can only take pieces diagonally, but can move forward if there is piece in front of them. So now we are going to address all of that cases. Pawns can't move two squares straight if there is piece in front of them. We are checking at the same time for both black and white pawns. If dx is equal to 2, it means that we are checking for white pawns. Otherwise, we are checking for black pawns. Also, I'm going to leave comment what we did here, in case someone watches code at GitHub repository. Also, now we need to do the same thing if pawn is moving one square straight. So same principle again, checking for both black and white pawns. Also, I'm leaving comment for this situation. And finally, we need to restrict pawn movements diagonally if that square diagonally is empty or has the piece that has the same color as the pawn that wants to move. Also, I'm leaving comment for this situation as well. Now open chessboard component TS file and declare private property selected square, which is type of selected square that we are going to define now. So create models.ts file in chessboard directory and declare type for square with piece, which is object that has piece of type FEN character as property, as well as x and y coordinates of that square. Now define type square without piece, that is object that for piece has null value, and finally declare type selected square, which is discriminated union between those types. Now import selected square. Initially no square is selected, and declare private property piece save squares, which represents save squares for selected piece as array of coordinates, which is initially empty array. Now open chessboard component HTML file and declare click event for selecting piece. Selecting piece function takes two arguments, x and y coordinates of that square, and in chessboard component TS file we are going to implement that method. Return type is void. Here we are declaring piece on that square, which can be piece or empty square. So if it is actually empty square, we need to return from the function as we're doing now. And also we need to update private properties for selected square and piece save squares. So firstly, update selected square by setting piece and x and y properties. And we need to update piece save squares now, but before doing so, open chessboard TS file and we need to declare property that holds save squares for the current player. So here define underscore save squares private property. And we are going to assign value in constructor by calling find save squares function. We also need to create getter for that private save squares property. And now go to chessboard component TS file and declare public getter for save squares. And now finally update piece save squares. We are going to apply certain CSS classes in case that square is selected or square is saved for selected piece. In order to achieve that, implement public isSquareSelected method that takes x and y coordinates as arguments and return type is boolean. If no square is selected, return false. And here we are checking if x and y from isSquareSelected method are equal to selected square x and y properties. Also implement public isSquareSave for selected piece method that also takes x and y coordinates as arguments and returns boolean. And here we are checking if piece save squares actually contains x and y coordinate. Now open Chessboard component HTML file and apply selected square class if square is actually selected. And also create new div and give it class save square if that square is actually saved for selected piece. Now you can notice that if I click on a square with a piece, it marks that square as selected and highlights its saved squares. So for now everything works fine, but however, as you can also observe, I can select squares with black pieces, even though it's white turn, so we're gonna address that bug, and also we need to create functions that allows us to move pieces. Now we're addressing bug for selecting piece with wrong color, so implement isWrongPiece selected method that takes piece as FEN character as argument and returns boolean. Declare boolean that says if white piece is selected. So if piece is equal to piece to uppercase, it means that white piece is selected. And now we need to return if white piece is selected and player color is black, or black piece is selected and player color is white. In that case, this method returns true. And now we are going to call that method in selecting piece to prevent selecting piece with wrong color. If I try to select black pieces when white is on move, you can see that I couldn't select them, which means that our method is working well and bug is resolved. We are in Chessboard TS file and implementing public move method that takes 4 arguments, previous x, previous y, and new x and new y coordinates, and return type is void. Now we need to check if those coordinates are valid. If they are not valid, we need to return from the function. Now declare piece variable, which is type piece or null, that represents item on previous x and previous y coordinates in the board. And now we are checking if piece is actually empty square or has color that is different than color of the current player. If it does, we need to return from the function. Also here declare piece save squares that we are going to get from save squares property. And now we need to check if new x and new y coordinates are actually in those piece save squares. If they are not, we need to return from the function because they are not save squares. So if those coordinates are not safe, throw an error. And now update the board. At previous x and previous y coordinates, we are setting null, and at new x and new y coordinates set piece. Also update player color variable, so if player was white, now it's black, and vice versa. And also we need to recalculate save squares after each move. If piece is pawn, rook or king and hasn't been moved, we need to set has moved property to true. Now open chessboard component TS file, and we are going to implement placingPiece method, which is private method that takes two arguments, new x and new y coordinate, and return type is void. Here we firstly need to check if square with piece is actually selected. Also we need to check if new x and new y coordinates are safe coordinates for selected piece. Now we are destructuring previous x and previous y property from selected square. And now we are going to call move function with previous x, previous y, and new x and new y coordinates. And also update chessboard view. Now create public move method, which takes x and y coordinates as arguments, and call both selecting and placingPiece functions. After calling both methods, go to chessboard component HTML file, and there, instead of selecting piece, call move function. Now you can see that our move function is working, but there is bug because save squares remain still, even though after I played move. Also, I couldn't take EnPassant. Also, I couldn't castle. And as you can notice, when I check black king, we should have some signalizations to mark that king is in check. So now we are going to address those bugs. Now implement private unmarking previously selected and save squares method that takes no arguments, and return type is void. So here, for selected square, say that no square is selected, and also set piece save squares to empty array. And now we are going to call that method each time we move the piece. We successfully removed bug that showed previously saved squares after we moved piece. Now we are going to fix bug that happens when we click on the square that has already been selected. So here we are checking if same square is clicked. So if selected square piece is not null and selected square x is equal to x and selected square y is equal to y, it means that same square is clicked. If it does, we need to return from the function. But previously we need to call private unmarking previously save and selected square method to unmark that square and save squares for that selected piece. Now if I click on square that is already been selected, it is unmarked, so everything works fine. Open models.ts file in ChessLogic folder and declare last move type, which is object that contains previous x property, previous y property, as well as current x and current y coordinates, and also piece that has made move. Now open chessboard TS file, and here after each move we need to update last move property, but firstly we need to define it. Declare private underscore last move property, which is type of last move or undefined, because it is initially undefined. And here implement getter for last move property. Now scroll down to move function and update underscore last move property. Set previous x, previous y, and for current x and current y set new x and new y, and also pass piece. We need to define property that tells us if king is in check. We have isInCheck method that returns if king is in check, so somehow we need to update that property in that function. But let's firstly see when that function is called. That function is called in isPositionSave after move method, but on simulated position. So we need to have some argument that tells us if we called that on simulated position or on the real one. So define checking current position boolean. In isPositionSave after move, call it with false. And firstly, in models, define type king checked, which is object that has isInCheck set to true, and also x and y coordinates of the king. Declare type king not checked, which is object that has isInCheck property set to false, and declare check state type, which is discriminated union between king checked and king not checked types. And now in chessboard TS file, declare private property underscore check state, which is initially set to king not checked. Import check state type. And now we are going to implement getter for that property. After we implemented getter for underscore check state property in isInCheck function, here when we returning true, we need to update the check state property if we are checking current position. And also don't forget to return true. Now we are going to do same for rooks, bishops, and queens. And finally, if king is not in check, but we are checking current position, we are also updating the underscore check state property by setting isInCheck to false. And scroll down to move function. After we changed player color property, we need to call isInCheck method. For current player, and for checking current position, we are passing true. Now open chessboard component TS file and declare private properties for both last move and check state. We are going to apply certain CSS classes in case that king is in check, or square is actually either starting or end square for the piece that last made a move. In order to do that, we need to create two functions. Firstly, define public is square last move that takes x and y arguments and returns boolean. Firstly, we are checking if last move is undefined. If it does, return false. Otherwise, we need to firstly destructure previous x, previous y, and current x and current y properties from last move. And here we are checking if x is either equal to previous x and y is equal to previous y, or x is equal to current x and y is equal to current y. Now implement method is square checked, which also takes x and y coordinates as arguments, returns boolean, and if is in check property of check state is set to true, and check state x is equal to x and check state y is equal to y, it means that king is in check. So in placing piece, after we called move function, I want to update check state and last move. And now go to chessboard component HTML file, and here append class last move if square is actually last move, and do the same if king is in check. Append king in check CSS class. Now, as you can see, those classes just set different box shadow for that square. We can see that last move class is implemented well as king in check. That is working good. But you will notice that I still don't have option to castle, so we are going to work on that. We are in chessboard.ts file, and here we are going to implement method canCastle. Here I have wrongly typed canCapture, but canCastle method takes king as argument, as well as kingside castle boolean, which signalizes if we want to castle kingside or queenside. Firstly, if king has been moved, we are returning false. Here specify king x and y position. King position x actually depends on the color of the king. So if king color is white, king position x is 0, otherwise it's 7. Declare king position y, which is 4. Declare rook position x, which depends on the color of the king, but is same as king position x. Rook position y depends on the kingside castle boolean. So if it is kingside, it's 7. If it's queenside, it's 0. So rook should be on rook position x and rook position y coordinates at the board. Now we are going to check that. Now if rook isn't instance of rook, or rook has been moved, or king is currently in check, it means that we can't castle, so we're returning false. Now define first next king position y, which is coordinate of y square through which king needs to pass. Here we are declaring for both king and queenside castling. Also declare second next king position y, that kings need to cross in order to castle. Now we need to check that both of those squares need to be empty. If either one of them is not empty square, we need to return false. In case that we want to castle queenside, we also need to check that chessboard at king position x and 1 need to be empty. Finally, we need to check if those squares over which kings needs to pass are saved squares. So that's the reason why we are calling isPositionSaveAfterMove function on first next king position y and second next king position y for y coordinate, and for x coordinate king position x. After we implemented canCastle method, we need to call that method in findSavedSquares function. So after we traverse all of the pieces direction, if piece is instance of king, we need to check for both queen and king side castling. So if king can castle king side, append to piece saved squares x coordinate, and for y set 6. Now we need to check if king can castle queen side. If it can, to piece saved squares append x, and for y append 2. Now let's play a couple of moves to get in the position where king can castle. Now you see that I have option to castle, but if I castle, castling is done incorrectly because rook didn't move at all, so this is the bug that needs to be resolved. Also you see that black hasn't option for castling because white bishop attacks that square over which kings need to cross. In order to fix bug for castling, in move function we are going to call another special function that updates the board. Implement private handling special moves method that takes 5 arguments. First is piece that has been previously moved, and others are its previous x, previous y, new x and new y coordinates. Return type is void. Here we are checking if piece is instance of king, and if absolute difference between its previous y and new y coordinates is exactly 2. If it does, it means that castling has happened. But if new y is bigger than previous y, it means that we castle king side, otherwise queen side. Now declare rook position x, which is same as previous x. Declare rook position y, which depends on the side where we castle. So if it's king side, it's 7. If it's queen side, it's 0. Now define a rook that we are going to get from board at rook position x and rook position y coordinates. Also declare rook new position y, which also depends on the side where we castle. So if it's king side, it's 5, but if it's queen side, it's 3. And now finally we need to update the board. So at chessboard rook position x and rook position y we are setting null because we are moving rook from that position. And at chessboard rook position x and rook new position y we are setting that rook, and also set that rook has been moved. Now we are going to call that function in move method. Now play a couple of moves just to get the position where both king can castle. Now you can see that I implemented king side castling well as queen side castling. Now we are going to discuss whether EnPassant capturing can occur. We observe that in the given position, white last move involved moving a pawn 2 squares, and now black pawn has the option to capture EnPassant. In order for the ability to capture EnPassant to be present, certain conditions need to be met, and these are: previous player moved a pawn 2 squares, our pawn and the opponent's pawn are on the same rank, And also pawns need to be adjacent to each other. And finally, position must be saved after capture is completed. If we look at this position, even though black moved pawn 2 squares, white pawn hasn't option to capture en passant, because if he has, he will create such a position that he is in check now, which means that this is unsafe position. We are in chessboard TS file and now implement private can capture en passant method that takes pawn as argument, as well as pawn x and pawn y coordinates, and returns boolean. If last move is undefined, we need to return false. Now destructure properties from last move object. And now in that if statement, we need to check if en passant can actually happen. So if piece isn't instance of pawn, or pawn color is different than color of current player, or absolute difference between current x and previous x is different than 2. Also, if pawn x is different than current x, or absolute difference between pawn y and current y is different than 1. So if any of those conditions are met, we cannot capture en passant. Now declare pawn new x position. For both black and white pawns. Now declare pawn new y position. Which is same as current y. And now we need to simulate how that position would look like. So at current x and current y, we are setting null, because we removed pawn from that position. Now we need to check if position is safe after that move. We need to restore position back. And finally we need to return is position safe boolean. Now go to find safe squares function, where we need to check if en passant can actually be completed. So if piece is instance of pawn and can capture en passant, we need to update piece safe squares. Here we are going to handle for both black and white pieces at the same time. We created position in which white has option to capture en passant, but if he captured, we didn't remove black pawn. So this is the bug that we need to resolve in handling special moves function, as we did for the castling. Now in handling special moves function, we need to check if en passant capturing has occurred. So if piece is instance of pawn and last move isn't undefined, and last move piece is instance of pawn, and absolute difference between last move current x property and last move previous x property is exactly 2. And also if previous x is same as last move current x, And finally, if new y is same as last move current y, it means that EnPassant has actually happened. And now we need to update the board. So now chessboard at last move current x and last move current y will be null. If white pawn captures EnPassant, we remove black pawn successfully and bug is resolved, but however there is another bug about pawn promotion. So if white pawn takes a rook, we should display promotion dialog, from which white player can choose in which piece he wants to promote his pawn. Now we are going to work on that. In chessboard TS file, implement private promoted piece method that takes one argument, promoted piece type, of type FEN character, and returns one of the piece in which we can promote our pawn, which is either knight, bishop, rook, or queen. And now if promoted piece type is either FEN character white knight or black knight, return new knight, and for color pass color of the current player. So now we are going to do same for bishop, rook, and queen. So if promoted piece type is either white bishop or black bishop, return new bishop. Do the same for rook. And finally, for queen. Go to move function and add one more argument for promoted piece type, which is FEN character or null. And here we need to check if promoted piece type is different than null. If it does, it means that promotion is happening and we need to update the board. So at new x and new y coordinates, we are not going to set piece, but rather result of the function promoted piece. Because if we set piece, we will place pawn on that position and we don't want to do that. So here call promoted piece for promoted piece type. And if promotion doesn't happening, we need to place piece at new x and new y coordinates. Now open chessboard components TS file. And we are going to declare properties for pawn promotion. First declare property is promotion active, which is boolean that signalizes if promotion dialog should be open and initially set to false. Also private promotion coords property, which is type of coordinates, or null and initially set to null. And promoted piece, which is type of FEN character or null, and by default is set to null. And create function public promotion pieces, which returns array of FEN character. So if the color is white, it will return array of FEN characters for white pieces in which we can promote our pawn. And those are FEN character white knight, FEN character white bishop, white rook, and white queen. And just copy that array and change white to black color. Now we need to fix bug because move function now takes 5 arguments, and for promoted piece type for now just pass null. And here we are going to handle promotion. So firstly, declare is pawn selected boolean. So if selected square piece is actually FEN character of white pawn, or selected square piece is black pawn, now we need to check if that pawn is on last rank. So if pawn is selected and new x is equal to 7 or new x is equal to 0, it means that pawn is on last rank. And now we need to check if we should open promotion dialog. So declare should open promotion dialog boolean. And if promotion isn't active and pawn is on last rank, it means that we need to open promotion dialog. So set is promotion active to true and also update promotion coordinates. And now we need to return, because now we wait for player to choose in which piece he wants to promote his pawn. Now open chessboard component HTML file, and now we are going to display that pawn promotion dialog. So here we have one div that is displayed only if promotion is active, and give class of promotion dialog. And now we need to loop through the result of promotion pieces function and to display each of the promoted piece. Add source tag. And also create button to close the dialog in case that we don't want to promote our pawn. But for now remove ng if condition to display dialog when is promotion active is set to true, because we want to show how the dialog would look in the browser. Now you can see how that dialog looks like. If I move white pieces, it changes color to black and again changes to white. Now in chessboard component HTML file, display dialog only when is promotion active is set to true. Now if I want to take a rook, dialog will be displayed and it will display me all of the pieces in which I can promote my pawn, but there is a bug because safe and selected squares are now also marked, and I need to create a function. When I click on a promotion piece, it will place that piece on the board. And also another bug, when I click on another piece, dialog still remains open, so we need to correct that. In chessboard component HTML file, declare click event for each promotion piece and pass promoted piece function that has one argument and its piece of type FEN character. Now in chessboard component TS file, we are going to implement that method. Return type is void. And here if promotion chords are null or selected square piece is null, we need to return from the function. Also update promoted piece property and set it to piece. Now we need to destructure properties from promotion chords. Now destructure previous x and previous y property from selected square. And now we need to update the board. So we should call placingPiece function, but we don't need to check for those if statements. So I'm going to create another function, private update board method, that takes previous x, previous y, new x and new y coordinates. Return type is void, and I'm going to copy code that updates the board and remove it in placingPiece function and just call update board. and copy that method and call it in promotePiece method. Let's correct isPositionSave after move function. Here I don't need to pass piece as argument, but rather I will read it from board at previous x and previous y coordinates. And if piece is null, we need to return false. And now every time that we called isPositionSave after move function with 5 arguments, we need to change that and call it with 4. Now go to unmarking previously selected and save square method and check if isPromotion active. If it does, set isPromotion active to false. Also set promotePiece to null. And set promotion chords to null. In updateBoard method, when we call move function, instead of passing null, we need to pass promotePiece property. Now, if we want to take a rook and pawn promotion dialog opens, we still have bug because save squares are highlighted. Also, we need to create function to close the dialog. And if we don't remove save squares when dialog is open, we have option to place pawn on square even though we didn't choose in which piece we want to promote our pawn. So now we are going to address that bug. In chessboard component HTML file, declare click event to close the dialog. And in chessboard component TS file, we are going to implement that method. Public close pawn promotion dialog. Takes no arguments and return type is void. And here we just need to call unmarking previously selected and save square method. In order to remove save squares when dialog is open, in placingPiece function, in if statement where we check if we should open promotion dialog, we need to set that piece save squares are now empty array. And finally, declare public method that will check if square is actually promotion square. So in that case, we can signalize which square we clicked when we want to promote our pawn. So if promotion chords are null, we need to return false. And now we need to check if promotion chords x is equal to x and if promotion chords y is equal to y. Now go to chessboard component HTML file and here append class if that function returns true for that coordinates. So append promotion square class. Now if we take a rook, save squares for pawn are now not highlighted anymore and we signalize our promotion square. Close pawn promotion dialog function works well. If we click on another piece when dialog is open, dialog will disappear. And if we want to take a rook, we see that now we can put pawn on its previously saved square, which means that previous bug is resolved. And now if I want to promote into a queen, everything works well. I couldn't move a bishop because black king will be in check. Now declare properties that will signalize us if the game is over. So firstly define private underscore is game over boolean, which is initially set to false, and also private underscore game over message, which is string or undefined. And now define getters for both properties. And also getter for game over. Now let's implement a method that checks if game is finished. Private isGameFinished method takes no arguments and returns boolean. And here, if player doesn't have any saved squares, it means that the game is over. And we need to check if it is a checkmate or stalemate. So if isInCheck property of checkState object is set to true, it means that player lost via checkmate. So here declare previous player. If current player is white, it means that previous player was black, and vice versa. And now update underscore game over message property and set previous player won by checkmate. Otherwise, update game over message and set that this is stalemate and return true. Otherwise, we need to return false. And finally go in move function, and after we calculated save squares, we need to update isGameOver property. We are going to handle situations in which draw is happening to a 50 move rule. Basically, this rule states that if no capture has been made or no pawn has moved in the last 50 moves, game is declared as draw. So here we are declaring private 50 move rule counter and set it to 0 and scroll down to move function. Declare isPiece taken boolean. And if square at new x and new y coordinates is different than empty square, it means that piece is taken. Now we need to check if piece is taken or piece that is last moved is actually pawn. If it does, we need to reset the counter to 0. Otherwise, we need to increment it by 0.5. And now go to isGameFinished method. And we need to see if 50 move rule counter is equal to 50. If it does, update game over message. And set draw to a 50 move rule. And return true. Now we are going to talk about insufficient material positions. A position is considered insufficient material position if neither side can mate the other. There are a couple of those positions, and we are starting with king versus king position. Also, if one side has exactly one minor piece, knight or bishop, it is also considered as insufficient material position. If one side have two knights and king versus king, it is also insufficient material position. If both sides have exactly one bishop of same colors, it is also considered as insufficient material position. And finally, if one side have multiple bishops of same color, position is also insufficient material position. We are not going to implement insufficient material function because it is trivial function and I don't want to spend time on it. I'm going to paste the code and we can see what we did in that method. So now we have a private insufficient material method that takes no arguments and returns boolean. Now we declared white and black pieces as array of object, and that object has piece, x and y properties. We need to have x and y because in some cases we can have bishops that are on same color. Now we are traversing the board and see if piece has white color. If it does, append it to white pieces, otherwise append it to black pieces. And now we are checking if white pieces has length of 1 and black pieces has length of 1, which means that this is king versus king position and we are returning true. Now we are checking if one side has king and minor piece against king. So if white piece length is equal to 1 and black piece length equal to 2, we are checking if black pieces has either knight or bishop. We are doing same for white pieces now. Here we are checking if both sides have bishop of same color. So if white piece has length of 2 and black pieces has length of 2. Now we are checking if both sides have bishop. If it does, we need to check if those bishops are on same color. So we are calling isSquareDark method. So if both white and black bishops are either dark or light, we are returning that boolean. Now we are checking if one side has two knights and king against king. For the sake of that, we define player has only two knights and king method, which simply filters the piece and see if that piece is actually knight and if the length of that filtered array is equal to 2. And finally, we are checking if one side has only bishops of same color against king. So we declared function and we are filtering bishops. And now we need to see if all of bishops are on same color. For the sake of that, we declared set and we mapped bishops array to see if square is actually dark, and if the size of that set is equal to 1, it means that all of the bishops are on same squares. And now we need to see if bishop's length is equal to piece length -1 because of king, and if all of the bishops are on same color. And finally, we are returning false if neither of these cases return to true. Finally, we need to call insufficient material method in isGameFinished method. Update _ game over message property and say draw due insufficient material position and return true. We are in Chessboard component TS file and here declare getter for game over message property. And go to Chessboard component TS file, and now we want to display that message if game is over. So if game over message is different than undefined, we need to display this message and give class game over message. Go to Chessboard component TS file, and now I want to prevent selecting and placing piece once game is finished. So here we are checking if game over message is different than undefined. If it does, we need to return from the function. And by doing so, we cannot call placingPiece method because we can't select square and set piece save squares, and hence placingPiece function will never be executed, and same is for promote piece. Now go to Chessboard TS file, and in move function, if isGameOver property is set to true, I need to throw an error that says that game is over and we can't play move. Let's play a couple of moves just to see if checkmate detection is working. And it does. Game over message is displayed, and you can see that now I can't select black pieces because game is over. Now we are going to see that stalemate detection is also working. Stalemate game over message is displayed. Now let's check for insufficient material position detection, and king versus king position is successfully detected. Insufficient material position for king and minor piece against king is detected. Insufficient material position detection is working in case that we have two knights against king. And it is also working in case that we have multiples bishop of same color. And finally, it is working in case that both sides have bishops of same color. Before we start to implement FEN Converter class, we need to define private full number of moves property, which is sixth and last part of the FEN string, which is initially set to 1. And now scroll back to move function. And after each move, when white is on move, we need to increment that counter. So here we are checking if player color is white. If it does, then increment number of full moves by 1. Now we are going to talk about FEN notation, which will help us in implementing method for detecting if same position is occurred 3 times during the game, and also we will use it when we want to receive move from Stockfish REST API to be able to play against computer. So we are in Wikipedia page, and for FEN says that it is a standard notation for describing a particular board position of a chess game. The purpose of FEN is to provide all the necessary information to restart the game for particular position. Here we have FEN string that consists of 6 parts separated via /character. So first part actually represents position of the board, but starting from the reverse. So we are first looping through black pieces, and black pieces are represented in lowercase letters. And if we have numbers, it means that those numbers are represented empty squares. Like now we have firstly 4 empty squares, then we have white pawn and another 3 empty squares, and rows are separated via /character. Second part of the FEN string represents player on the move, which can either be W or B for white and black pieces. Third part represents right for castling, so K means that king has right to castle king side, while Q means that king has right to castle queen side, and uppercase letters are for white player and lowercase are for black player. And if neither side have ability to castle, we need to return dash. Fourth part is actually represent EnPassant target square, so if there is no option to capture pawn in EnPassant, we return dash. And fifth part is actually represent half move clock, which is the number of half moves since the last capture or pawn advanced is made. And finally, last part represents full move number, which is number of the full moves. It starts at 1 and it is incremented after black move. Now create new file, FEN Converter TS, and declare FEN Converter class. And now we are implementing method that converts current board position to FEN string. That method takes couple of arguments. First is board, which is two-dimensional matrix of pieces or null. Also player color. Last move, which is last move or undefined. 50 move rule counter. And finally, number of full moves. Return type is string. And here declare that FEN string as an empty string that we need to return from the function. Now we need to loop through the board and get first part of the FEN string, which represents position of the board. And we are doing that from reverse because this is how FEN is defined. Now declare FEN row, which represents a row of board as FEN string, and initially set to empty string, and also declare consecutive empty squares counter and set it to 0. Now we need to loop through each square of the row. If that square is empty, we need to increment consecutive empty squares counter and continue. But now if consecutive empty squares counter is different than 0, in FEN row string append that value for consecutive empty squares counter as string. And also we need to reset the counter. And append piece FEN character property to FEN row. And now we also need to check if consecutive empty squares counter is different than 0, which means that a row ends with empty square. And now also append consecutive empty square counter as string to FEN row string. And finally, we need to update the FEN string. So if I is equal to 0, it means that it is last row. FEN rows are separated via /character, but that doesn't count for last row. Now we finished with first part of the FEN string. Now define player color. So if player color is white, then second part of the FEN string will be W, otherwise it would be B. Now create private method, castling availability, that will tell us if white and black king have rights to castle both king side and queen side. So here we are passing board, return type is string. Here declare casting possibilities function that takes color as argument and returns string. Here declare casting availability as an empty string that we need to return. In order for king to have ability to castle, its has moved property must be set to false. So here firstly get king position X, which depends on the color. So if the color is white, it is 0, but if it's black, it's 7. And here get king from the board. King is at king position X, and for Y 4. Now we need to check if king is actually instance of king, and if has move property is set to false. Now we need to get a rook position X, which is same as king position X. Now declare king side rook, which is at rook position X and 7 for Y, and declare queen side rook, which is at rook position X and 0 for Y. Now we need to check if those rooks are actually rooks. So firstly for king side rook, checking if it is instance of rook, and if it has no property set to false. If it does, in casting availability, append K. Also doing same for queenside rook. Append lowercase q. And finally, if the color is white, we need to represent casting availability in uppercase. And finally, we need to return casting availability. Now call casting possibilities function for both black and white king. Now we need to check if casting availability is actually empty string, which means that neither side have right to castle. If it does, we need to return dash, otherwise we are returning casting availability. And as we declared casting availability method, now we need to do same for EnPassant possibilities. So here declare private EnPossibility that takes last move as argument, which is type of last move or undefined, and also takes color, which is color of the current player, and returns string. So firstly we need to check if last move is undefined. If it does, return dash. Otherwise we need to destructure properties from last move. Now we are checking if last move involved moving a pawn 2 squares. So firstly check if piece is instance of pawn, and if absolute difference between new x and previous x is exactly 2, which means that there is possibility to capture that pawn in EnPassant. Firstly declare a row of that target square, which depends on the color. So if the color is white, it is 6. If it's black, it's 3. And now we need to return that target square. So firstly, we need to define columns in models.ts file, which represents columns of the board from A to H. And here we need to return exactly coordinates of that square as strings. So we are returning columns of previous y plus string of row. If that square doesn't exist, return dash. And now we need to call casting possibilities and EnPassant possibility function in convert board to FEN. So firstly, append to FEN player, which is second part of the FEN string. And FEN parts are separated via space character. So third part is actually casting availability string. Fourth part represents EnPassant options. Fifth part represents 50 rule move counter multiplied by 2. And last part is actually number of full moves. We are going to implement a method that detects if same position is occurred 3 times during the game. For the sake of that, declare private property, threefold repetition dictionary, which is map that for its key have string and for value has number. And also declare private threefold repetition flag property, which is initially set to false. After each move, we need to update threefold repetition dictionary. For the sake of that, implement private update threefold repetition dictionary method that takes one argument, and it is FEN string, and return type is void. Here declare threefold repetition FEN key, which represents first 4 parts of the FEN string. Because if they are same, it means that position is repeated. And now we need to see if that key actually is in map. Now we are checking if threefold repetition value is undefined. If it does, we need to update threefold repetition dictionary map. And for threefold repetition key, set value of 1. And now if that key is present in map, we are checking if this value is equal to 2, which means that now we are repeated position 3 times, and set threefold repetition flag to true, and we are returning from the function. Otherwise, we need to set a value for threefold repetition key to 2. Now go to isGameFinished method. And here we need to check if threefold repetition flag is set to true. If it does, we need to update underscore game over message property and return true. So set draw do threefold repetition and return true. We need to have some property that holds board position as FEN string. For the sake of that, declare private underscore board as FEN property, which is string. And here I pasted FEN string for the start position of the game. Now instantiate private property FEN Converter. We now need to implement getter for underscore board as FEN property. Now scroll down to move function, where we need to update _board as FEN property after each move. So here we are in move function. Cut this line and paste it at the end of the function. And finally update _board as FEN property by calling convertBoard to FEN method of FEN Converter class. And here pass Chessboard as first argument, then player color, then last move, also 50 move rule counter and number of full moves. And finally, after we updated _board as FEN property, we need to call update threefold repetition dictionary and pass _board as FEN as argument. Now we are going to repeat same position 3 times just to see if our method is working well. And if we can see it does, draw to threefold repetition rule message is displayed. We are in Chessboard component TS file, and now we are going to implement a method that will rotate the board. So firstly declare public flip mode boolean, which is initially set to false, and now implement flipBoard method that takes no arguments and return type is void, and it simply inverts the flip mode property. Now go to Chessboard component HTML file, place pawn promotion dialog outside of the Chessboard div. Here declare button that flips the board and append click event. And for function set flipBoard. And now we are going to append rotate CSS class in case that flip mode is set to true. We need to do that for div chessboard and also for each piece. Now in Chessboard component CSS class, firstly set width and height for Chessboard class, and also declare rotated class that simply rotate the board for 180 degrees. Now we can see that the flipBoard function is working. I can successfully rotate the board. Open terminal and generate computer mode component in modules folder and skip tests. Now generate Stockfish service in computer mode folder. And also skip tests. Now go to app module TS file and here import HTTP client module. From Angular common HTTP. Now go in computer mode and in Stockfish service TS file, inject HTTP through constructor. Now let's take a look at Stockfish REST API website that we are going to use in order to be able to create mode to play against computer. Firstly, I need to say that while I was recording this tutorial, version of this API has changed and now you don't need to create multiple requests to get best move, evaluation and top engine line. Initially in the video I used old API, but later you can find part where I make certain changes and application is now compatible with the new version of API. Now if I click on send get request, I receive response from the Stockfish, and in docs we can get more information about that. So here is the endpoint for this API, method is get. We need to send 2 parameters to that method. First is FEN string that we want to analyze, second is depth for engine to go, which is integer below 16. For success we can either have true or false, and if value is true we receive object that is look like this. So first we have evaluation, which is number, that is evaluation of the current position that we get from Stockfish. Mate is null unless there is forced checkmate in the given position. Best move is in this format, where first part is best move string. Then we have space character. Second part is computer move, where first two letters represent starting coordinates of that move and coordinates of that move. And that second part can sometimes have 5 letters, where last letter represents piece in which computer wants to promote his pawn. And finally we have top engine line. Now create private read-only property for API endpoint, and here I pasted version of the old API. Then in computer mod folder create models.ts file, and here I'm going to declare type for Stockfish query params, which is object that has FEN as property, which is type of string, depth, which is number, and third parameter, which is mode, but later we will see that we don't need to have that mode property. Now go to Stockfish service TS file, and we are going to implement method to get best move from the computer. That method takes FEN string as argument. Return type is observable of chess move, which is custom type that we are going to define now. So now go in models.ts file, and here declare that chess move type, which is object that has previous x property, which is number, previous y, as well as new x and new y, and also promoted piece, which can be FEN character or null. Now go back to Stockfish service, and now import both chess move and observable. Here declare query param object that we are going to send with get request. So pass FEN, for depth say 13, and for mode set best move, because this is old API. Create HTTP params object and append query params to that. Now go to models.ts file, and here declare one more type, which is Stockfish response, that is object that has success of type boolean as property, as well as data, which is of string. Now we are sending get HTTP request. Now import switch map operator, and we want to create new observable from that response. Now declare best move that we will get from response data, but we need to split that via space character and to get second part of that. And best move is type of string in format b6 b7, and we need to convert that string into chess move type. That's the reason why we are implementing now private move from Stockfish string method that takes one argument, move of type string, and returns chess move. But because this response is in format b6 b7, we need to have another function that will convert that letter to y coordinate. Now we are implementing that method. Takes one argument of type string, returns number, and we need to subtract char code of that string with char code of lowercase a, declare previous x. Previous x is actually number of second character in move string, -1. Here declare new y, and we also need to call convert column ladder to y coordinate. For third ladder, declare new x, and finally, if you remember, best move from Stockfish can sometimes have 5 ladders, and that 5th ladder represents promoted piece, so we need to handle that situation as well. That's the reason why we are implementing promote piece method that takes piece as argument of type string or undefined and returns FEN character or null. So if piece is undefined, we are returning null. But if piece is equal to lowercase n, we need to return FEN character black knight. Now we are assuming that computer plays with black pieces, but later we are going to change that. So if piece is b, we need to return FEN character black bishop. If piece is equal to r, return FEN character black rook. And finally, return FEN character black queen. Now declare promoted piece and call promoted piece method for last letter of the Stockfish string and return chess move type. Now after we finished with move from Stockfish string, we need to call that function in getBestMove. So here we are returning new observable of result of the move from Stockfish string function. Now open computer mode component TS file, and here computer mode component class extends chessboard component class. And also for HTML template, set HTML template of chessboard component. And also use CSS from chessboard component. And also we can delete chessmod component CSS and HTML files. Now open terminal, and we want to install Angular material. Choose custom theme. We don't want to use typography styles, and also don't include animations. Now generate nav menu component. And skip tests. Now we are going to implement routing. In app folder, create a routes folder. And in routes folder, create app routing module TS file. For now, declare empty arrays of imports and exports. Then declare app routing module class. And now declare routes. We will have 2 routes. First is to play against friend, and second is to play against computer. Also add title. And now in imports, add router module for root routes. In exports, add router module. And here open up module TS file. And in imports, include app routing module class. Now go to nav menu component. Open nav menu component TS file. And here mark it as standalone component. And import mat toolbar module. As well as button module. Now we need to import mat toolbar module and mat button module from Angular material. Now open up module TS file, and here we need to correct error because nav menu component is now standalone component and need to be included in imports array. And now go to nav menu component HTML file, where we are going to declare basic HTML for nav menu component. We will have two buttons and add router link to against friend mode. And also add another button to play against computer. Also add router outlet. And then in nav menu component TS file, we need to import router module. And finally, go to app component HTML file and remove app chessboard component and append app nav menu component. This is how our application looks now. So we have nav menu component and two buttons for play against friend and play against computer. But for now, play against computer component is same as play against friend component, and now we are going to work on that. Now go to computer mode component TS file, and here we want to inject Stockfish service through constructor. Also we need to call super constructor. Now implement ng on init. Now we are going to subscribe to Chessboard state behavioral subject from Chessboard service, because after each move is played, we want to see if computer is on move, and then to call get best move method from Stockfish service. But first open Chessboard component TS file and mark Chessboard service as protected. We receive FEN as response. And now we need to check which player is currently on move. This is second part of the FEN string. Now, if player is white, we need to return from the function because we initially set that computer is always playing with black pieces. And now we are going to call method to receive best move from Stockfish string. Pass FEN to get best move function. And this type is observable of chess move. So now we need to convert that observable to promise using first value from RxJS operator. And also mark that function as async. Now we are going to destructor Stockfish move. Before we call updateBoard method in computer mode component, we need to mark it as protected. And then we are going to call updateBoard method and pass previous x, previous y, new x, new y, and promoted piece. Then declare private subscriptions property that is going to hold all of the subscriptions that we declared in ng-onInit method. Add Chessboard state subscription to subscriptions. Now implement onDestroy lifecycle hook. And in ng-onDestroy method, we are going to unsubscribe from those subscriptions. We are in computer mode component, and after I play move, I receive move back from computer. And now, as you can see, everything works fine. Now open terminal and generate play against computer dialog, which is component that will allow us to choose to play with black or white pieces against computer, and also skip tests. Now go to play against computer dialog component. Mark component as standalone. And here import mat dialog module, mat button module, and common module. Then declare public property Stockfish levels that represents different levels of Stockfish strength. Also declare current Stockfish level that we choose, which is initially set to 1. Now we are going to implement HTML for play against computer dialog component. Now declare title for dialog. Then we need to display Stockfish levels from which we can choose to play. Now we are looping through all Stockfish levels. Add class strength div. Also add button that is going to close the dialog. Now go to app module, and play against computer dialog component is standalone, so include it in imports array. Open play against computer dialog component CSS file, and here I pasted code for CSS that you can find on GitHub repository. Then open play against computer component HTML file, and here I'm going to create two images for black and white king. So when I click on one of those images, I can choose color for my pieces. Also set draggable attribute to false. Go to nav menu component TS file. And here we are going to implement a method that will open the dialog once we clicked on play against computer mode button. So here import mat dialog module. Then go to nav menu component HTML file, remove router link, and here add click event, and add play against computer function that takes no arguments. Now we are going to implement that method. Return type is void. We need to inject dialog through constructor. And open the dialog in play against computer method. Correct typing mistake for CSS class. Dialog component is working well, but now we need to create functions to choose level of Stockfish and also to choose player color. Now declare click event for Stockfish levels. Select Stockfish level method takes level as argument. Now we are going to implement that method. Return type is void. And here update Stockfish level property. Now go back to HTML file. And here we are going to add CSS class that will signalize if that level is selected. So append selected CSS class if level is same as Stockfish level. Then declare click event for both kings. We're going to have play function that takes one argument, which is either W or B. Now let's implement that method. Return type is void. And here we need to go to models TS file in computer mode component and declare a new type, which is computer configuration, which is object that holds two properties. And first is color of type color, and also level of Stockfish, which is type of number. But now we also need to map that levels to Stockfish depth. For the sake of that, we declare constant Stockfish level, which is read-only object. And here just map levels to Stockfish depth. Go to Stockfish service TS file, and here declare public behavioral subject property that is of type computer configuration. And for initial value, set the color is black. And for level, set 1. Now open play against computer dialog component TS file. We need to inject Stockfish service through constructor. Also, we need to inject dialog component. And now when we click play function, we need to close all dialogs. Computer configuration behavioral subject needs to emit new value once we click play function. Here we are setting value for color. Here I have wrongly typed color white, but should be color black if we choose to play with white pieces. That mistake will be corrected later. And for level, set Stockfish level. Also, we are injecting router. So once we click on play function, we should navigate that to computer mode component. And also create click event to close the dialog. Dialog is closed by default, but we are going to navigate to play against friend component if we choose to not play against computer. Then implement close dialog method that takes no arguments and return type is void, and we simply need to navigate to play against friend component. Then go to computer mode component TS file, and here we are hard coded that computer is always playing with black pieces. Now we are going to change that. And now we are checking if player is different than computer configuration value for color. If it does, we need to return from the function, because this is not computer move. If we choose to play against computer with the black pieces, I want to rotate the board so black pieces would be closer to us. Here, declare computer configuration subscription. And we want to subscribe to computer configuration behavioral subject. And now we need to check if computer configuration value for color is white. If it does, we need to call flipboard method. Also, we are going to append that computer configuration subscription to subscriptions property. Then go to Stockfish service TS file. And here in getBestMove method, you see that we hard-coded 13, but rather we are going to pass value from computer configuration behavioral subject for level. Now go to Chessboard component TS file and mark private chessboard property as protected. Then go back to computer mode component.ts file, and here we need to check if game is actually over. So if game is over, we need to unsubscribe from Chessboard state subscription. And also to return, because we don't want to generate computer move once a game is finished. Then go to play against computer dialog component and fix the bug that we said earlier for computer color. Finally, go to Stockfish service.ts file where we need to handle last bug. You can see that private promote piece method is only handling situations when computer is playing with black pieces. That's the reason we have now computer color variable that we get from computer configuration behavioral subject. And now we need to check if computer color is white and then to return FEN character white piece, otherwise we are returning FEN character black piece. Now we need to correct that for each knight, bishop, rook or queen promotion. Now do same for rook. And finally for queen. Now we fixed method. We are going to make certain changes in order to make application compatible with new API. Firstly, change API endpoint, then remove mode property from Stockfish query params object, and also remove data from Stockfish response. And instead of data, we will have evaluation property, which is type of number or null, mate, which is also number or null, best move of type string, continuation of type string. Then in Stockfish service.ts, remove mode. And here we need to access response best move property. And finally go to play against computer dialog component.ts file. And here instead of passing Stockfish level, we need to pass Stockfish levels, which is map, and access here Stockfish level. We can see that our application works well. I can select different level for Stockfish strength and also for color. Board is rotated automatically if I choose black pieces. Now open models.ts file in ChessLogic folder. And here declare enumeration for different move types. We have capture, castling, promotion, check, checkmate, and basic move. And append new property in last move object, which is move type of type set of move type enumeration. Then open chessboard.ts file, scroll down to move function, and you will see an error because last move now has one additional property, which is move type. So we are going to declare move type as an empty set of move type enumeration. And now if piece is taken, it means that capture is happening. So append capture to move type set. Also add move type for last move object. And here if promoted piece type is different than null, it means that promotion is happening. So also append promotion in move type. And also we need to pass move type as handling special moves argument. Go to handling special moves function. And here if castling is happening, add castling. And also if EnPassant is happening, add capturing. Again, go to move function, and here we need to check if checkmate or check is happening. So if isInCheck property of check state object is set to true, and if player doesn't have any saved squares, it means that it's a checkmate. Otherwise, it is a check position. And also, if move type set doesn't have any elements, we need to append basic move. Now go to models.ts file, where we are going to declare type that is responsible to hold list of previous moves. Move list type is array of tuples, and first element of tuple is string and second is optional string. Now declare game history type, which is array of objects, and that object has last move property, which is type last move or undefined, as well as check state property of type check state, and board, which is two-dimensional matrix of FEN character or null elements. Then go to Chessboard.ts file. Here declare properties for those types. So firstly declare private underscore move list, which is of type move list, and initial value is empty array. Declare underscore game history property of type game history, and we are going to assign value to that in constructor. Now let's implement getters for both last move and game history properties. Now we are going to implement a method that is responsible for storing move. So here implement private store move method that takes no arguments and return type is void. Now destructure properties from last move object. Declare piece name. So in case that piece is pawn, piece name is empty string, otherwise it's piece FEN character property. Now declare move, which is initially empty string. And here we need to check if move type from last move object contains castling, which signalizes that castling is happening. If it does, we need to check if it is actually kingside or queenside castling. In case that current y is bigger than previous y, it means that this is kingside castling. And this is notation for kingside castling and for queenside castling. Otherwise, for move add piece name and also include initial coordinates of the piece. So this is long notation. Later we will make certain changes and make it shorter. Also we need to check if capture has happened. If it does, append X sign to move. Also include end coordinates. we need to check if promotion is happening, so append promoted piece, which is type FEN character or null, as store move function argument. And here, if promoted piece is different than null, append equal sign plus promoted piece to uppercase. Finally, we need to check if check or checkmate has happened. So here we are checking if check is happened. If it does, append plus sign to move string. And if checkmate has happened, append hash symbol to move. Now we need to store that move in moveList property. So here we are appending move for white. And now for black. Then we are going to implement a method to update game history. Takes no arguments and return type is void. Now we need to update underscore game history property. So for board, we are creating deep copy of chessboard view property. Now we need to create deep copy of check state object. And same for last move. But firstly we need to check if last move is undefined. Then go to move function. And here we need to call store move method and update game history method. Now open terminal and generate moveList component in modules folder. And also skip tests. Go to moveList component TS file. Mark component as standalone. And now import common module, mat button module, and mat icon module. Go to moveList component HTML file. And I'm going to paste basic HTML for navigating between moves. So we are having navigate to first move, to move before, to move next, and to last move. Also, we need to correct error because moveList is standalone component and needs to be included in imports array. Go back to moveList component TS file and here declare input property moveList, which is the required property. Then open moveList component HTML file. And here we want to render those moves from moveList. So create div and add class moveList. Now we need to loop through each move of moveList. Also declare move number, which is index, and append class of row. First append white move, and then we should check if black has played. If it does, we also need to append black move, and we give class move for that div. And also I'm going to paste CSS, which you can find on GitHub repository. Then open Chessboard component TS file. And here declare getter for move list. Now open Chessboard component HTML file. And here we want to append move list component. And also pass move list property. Play a couple of moves just to see how our move list component looks so far. So this is long notation, later we will change it to short notation. But also we need to implement functions, so each time I click on move in move list component, it should render me that position. And also to navigate using arrows. In Chessboard component TS file, declare getter for game history. And declare public property game history pointer, which represents move that we are currently on in move list component, and initially set to 0. So scroll down to update board method, and each time we call move function, we need to increment that game history pointer. Now go to move list component TS file and add another input required property, which is game history pointer, and initially should be set to 0. Here I wrongly set it to 1, but we'll correct that. Then go to Chessboard component HTML file and add input binding to game history pointer. Then go to move list component HTML file. And here also add move number. Which is move number plus 1. And also we need to check which move we are currently on and to add class current move. So here we are checking if move number times 2 plus 1 is equal to game history pointer. And for black pieces, we are checking if move number times 2 plus 2 is equal to game history pointer. Now we successfully added current move class. Go to move list component TS file and declare one more input property, which is also required. And it is game history length, which is length of game history property of chessboard class, and has initial value of 1. And now we need to make binding for those property. So go to chessboard component HTML file and add input binding for game history length and say that this is game history length. We are going to disable navigation buttons in move list component. So disable navigating to initial game position if game history pointer is equal to 0. Also disable navigating to move before if game history pointer is equal to 0. Disable navigating to next move if game history pointer is same as game history length minus 1. And do the same for navigating to last move. Finally, we need to declare output property, which is event emitter, that will emit new value after we click on certain move in move list component. And that emitter will trigger function in chessboard component that will show us position of the board when that move has been played. So here we declared show previous position event output property, which is event emitter of type number. And here declare show previous position method that takes move index as argument of type number, return type is void, and it simply emit new value for show previous position event emitter. And now in moveList component HTML file, we need to call show previous position method for each of the navigation buttons and for both black and white moves in moveList. So firstly declare click event for navigating to 0 move, also to navigating to move before, and pass for argument game history pointer -1. To navigate to next move, add click event to navigate to game history pointer +1. And to navigate to last move, call show previous position method for game history length -1. And now also call it for both black and white moves in move list. Call show previous position for move number times 2 + 1 if the move is white. And call show previous position for move number times 2 + 2 for black move. Then go to chessboard component TS file and here declare show previous position method. This takes move index as argument of type number and return type is void. And here we need to update check state, board and last move property. And first we need to destructure them from game history at move index. And now update chessboard view, check state, and also last move. And finally update game history pointer. And finally add output binding to up move list component. Now let's see how move list component looks now. Initially every navigation button is disabled. And after playing a couple of moves, you can notice that buttons that navigate to next move and to the last move are disabled. And also if I click on a certain move in move list, position will be displayed when that move has been played. And this is same for navigation buttons. Now we are going to implement a method that will convert long chess notation in short notation. Firstly, we need to remove coordinates of initial square. Then here implement private starting piece chords notation, which takes no arguments and returns string. Firstly, we need to destructure properties of last move object. Then we need to check if current piece is instance of pawn or king. If it does, we need to return empty string. Because we only have one king, and for pawn we are handling that situation later. And now we need to have array of coordinates that represents all pieces of the same type that have same target square as piece that just made the move. So here for x add previous x and for y add previous y. Now we need to loop through the board and see which piece of same type has exactly same target square as initial piece. Declare piece on that square, which is either piece or null. And now if piece is null, or x and y are same as current x and current y, this means that this is the same piece and we need to continue. And now if piece actually has same FEN character as current piece, we need to check if that piece had same target square. Now let's get save squares for that piece from underscore save squares property. Now we need to loop through that save squares and see if that save squares contains coordinate that has x which is equal to current x and y which is equal to current y. And if it does, we need to append those coordinates in same pieces chords. If same pieces chords array has length of 1, it means that there are no pieces of same type that had same target square as piece that made a move. Hence we need to return empty string and now declare two more sets. And those sets are important because from them we can conclude how many same type pieces that had same target square shares both x and y coordinates. So firstly we declared pieces file set that represents pieces that shares y coordinate. Going to do same for x coordinate, pieces rank set. And now we need to check if pieces file size is same as same piece chords length. If it does, it means that all of the pieces are on different files. Hence we are returning columns at previous y index. Also I'm going to leave comment for that case. Now we need to do the same for pieces rank. So if pieces rank size is same as same pieces chords length, it means that all of the pieces are on different ranks. For example, 1, 2, 3, and so on. Hence we need to return string from previous x plus 1. Also I'm leaving comment for this one. And finally, if none of these if statements returns to true, we need to specify both column and rank. Also, I'm leaving comment for this case. So that's the situation where multiple piece shares both rank and a file. Now go to store move function and here call starting piece chords notation method. Also here when we are checking for capturing, we need to see if pawn is piece that last move. Because if it does, we need to include its previous column. That's because in starting piece chords notation method, if current piece is pawn, we returned empty string. And now, as you may already notice, there is a bug in this approach because in starting piece chord notation method, when we get save squares for piece, we use it save squares after they've been calculated for next player in move function. As you can see right here. So we called store move function after save squares are being calculated. So we need to store save squares in some variable and update underscore save squares property after we called store move function. And also in store move function, piece name FEN character should be uppercase. Now we are going to see if short notation method is working. Play a couple of moves. And now we will get in position where both B and F knights can go to same square, and we specified that this is B knight, so method is working. We are in Wikipedia page that talks about chess notation, and they provide some example where multiple pieces share either column, rank or both, and we are going to replicate that position. So in our chess application, we are playing same moves as they were playing, and everything works. For queen, we need to specify both initial column and the rank because multiple queens share both rank and a file. Now we are going to emit a sound after each move is played. So we have sound folder that represents different sounds of each move type in assets folder. And now open chessboard component TS file where we are going to implement a method that will emit new sound after each move. Here implement private move sound method. And declare basic audio element, and for its source set source of basic move. That private method should take one argument, and this is move type, which is set of move type enumeration. Now we are checking if move type set contains promotion. If it does, we need to update source for move sound. Now we are going to check for both castling and capturing. Now we are checking for both checkmate and check. They have higher presence than promotion, capture and castling sound. Here correct mistake. And now finally we need to emit that sound. In move sound function, I have typing mistake because I double checked for checkmate, should be for check. You can see that we manually update check state and last move property in show previous position method, and we are doing same in update board method, but rather we are going to create method that marks check state and last move. So here implement private mark last move and check state. That method takes last move, which is type last move or undefined, as well as check state of type check state, and return type is void. And here we are assign last move to last move property, as well as check state to check state property. And now we are going to emit sound. So if last move is different than undefined, we are calling moveSound function. And here pass move type from last move property. And if last move is undefined, it means that we are going back to first move. So here just emit new set of basic move. Now we need to call mark last move and check state method. So here in update board, pass chessboard last move and chessboard check state properties. And do same in show previous position method. Pass last move and check state that we are destructure from game history. Now, as you can hear, move sound is emitted after each move. It is working for basic move and for capturing, as well as for check, and for castling. Also, if I navigate between moves in move list component, move sound is played. Also, when I promote my pawn, different audio is emitted. Here is the sound of checkmate. Now we are going to create a method to navigate between moves in move list component using left and right arrow key. So firstly, implement onInit lifecycle hook. And here declare key event subscription. So we are getting event from keyboard. For whole document, and event that we are listening is key up. Now we need to filter those events. So we are only listening to right and left arrow keys. Now we are going to define functionalities in tab operator. So we need to import it from RxJS. And here declare switch statement. So if we have arrow right, we are checking if game history component is same as game history length -1. In this case, we cannot go any further, so we need to return. Otherwise, we need to increment game history pointer. For left arrow, we need to check if game history component is equal to 0. In that case, we need to return. Otherwise, we need to decrement game history pointer. And finally, we need to call show previous position method and pass game history pointer. Also, we need to subscribe to that from event. And we need to define private subscriptions property that is going to hold all of the subscriptions defined in chessboard component TS file. Now add key event subscriptions in subscriptions property. Also, we need to implement onDestroy lifecycle hook. And here we need to call subscriptions unsubscribe. Now go to computer mode component TS file. And here we need to call base ng on init from Chessboard component class. Also, we have same subscriptions property, so we need to rename it to computer subscriptions. Also, we need to override ng on init and ng on destroy in computer mode component class. And also call super ng on destroy. As you can see, we implement navigating between moves in move list component using arrows well, so everything is working.